All right, today we're going to cover topic 3.4, which is the derivatives of inverse trig functions here in AP Calculus. And what we have is there's all these formulas. Here they are, and these are all the formulas, the complete rules for finding the derivatives of inverse trig functions. And if you look at these, you see that they all have a tendency to look a lot alike. So what I'm going to show you is a way for finding this formula for, it's not a proof, it's a way of finding the formula so that you can come up with the equation if you need to. All right, so let's look at this first problem here. What we're going to do is we're going to work from this down to the actual derivative. So let's start right here. If y equals the arc sine of x, and if you look over here, we have some steps for us. Let's take the sine of both sides. So the sine of y equals the sine of the arc sine of x. And we know that if I take the sine of the arc sine of x, it's just equal to x. So now I have the sine of y equals x. All right? And so what we're going to do next is we're going to differentiate both sides with respect to x. But before we do that, let's come over to our triangle and label this. We'll call that angle y. And because I know that the sine of an angle is opposite over hypotenuse, we're going to call this the x and this the 1. All right. Now, what would that make this third side be? Well, if we do a little Pythagoras, if I call that third side, let's just call it a, then I would have a squared plus x squared equals 1 squared. And if I solve for a, I have a squared equals 1 minus x squared, which means that third side is the square root of 1 minus x squared. We will need that in a minute. All right. So back to number 3, finding the derivative. Well, the derivative of the sine of y is the cosine of y times dy dx, and that equals the derivative of x, which is just 1. All right. Then we're told to isolate y prime. So if I get dy dx by itself, I have the dy dx equals 1 over the cosine of y. And so now we use the identity and we just find out what is the cosine of y. All right, the cosine of y is the adjacent side, all right, over the hypotenuse. So that is 1 over the square root of 1 minus x squared, and there is my derivative. That is the derivative of the arc sine of x. And if you look at this list of formulas that I gave you, right here, you will see that formula. All right? And so literally, we could work through any of these using this method to come up with our formula. All right? And so that's why I included several of these boxes here. They all say arc sine of x. But what if I had the arc secant of x? All right, and I wanted to come up with the formula for that one. Well, I would start the same way. I would take the secant of both sides. The secant of y equals the secant of the arc secant of x. So the secant of y equals x over 1. All right. Now remember, secant is just like 1 over cosine, right? So we have to flip the cosine instead of adjacent over hypotenuse. It's hypotenuse over adjacent, all right, if this is my y, all right? So now, when I do that little trick that I showed you, it's not a trick, just Pythagoras, if I call this side a, I now have 1 squared plus a squared equals x squared, all right? So a squared is x squared minus 1, and in this case, it's the square root of x squared minus 1 instead of the square root of 1 minus x squared. All right? So now we need to take our derivative of both sides, all right? And the derivative of secant, if you remember what the derivative of secant is secant tangent. Yes? The derivative of secant is secant y tangent y dy dx equals 1. So if I solve this, I have dy dx equals 1 over the secant of y times the tangent of y. All right? So now if we come over to our drawing over here, the secant of y is going to be, instead of adjacent over hypotenuse, it's going to be hypotenuse over adjacent. So I'm going to have 1 over just x, all right, because it's x over 1. The tangent of y is going to be opposite over adjacent, so it's going to be the square root of x squared minus 1. All right, now I do need to point out something here. This x should have an absolute value around it. Why? Because we're talking about this x right here, and that is a hypotenuse, and a hypotenuse is always positive. You think of how the Pythagorean theorem works, that has to be positive. So, and if you look at our list of formulas here, all right, there is our formula. Now, why do all of these have du dx's? Because we have to do the chain rule. All right, using these formulas is really easy. We just have to follow the chain rule. All right, so let me back up for a second and do a very basic problem. Let's say that I wanted to find the derivative of the arc sine of 2x. All right, well, my formula that I just showed you for the derivative of the arc sine of x is 1 over the square root of 1 minus x squared times du dx. All right, so all I have to do is, on this problem, this 2x goes where this x is. So it's going to be 1 over the square root of 1 minus 2x squared. And then I need to multiply it by the derivative of that thing we're taking the arc sine of. So the derivative of 2x is just 2. All right? So there's my answer. It's just 2 over the square root of 1 minus 4x squared. So using these formulas are really easy. Let's do another one. All right, let's start with our formula for the arctangent of x cubed. And our formula is right here, 1 over 1 plus u squared times du dx, 1 over 1 plus u squared times du dx. So that means I need to put this thing in right here. So I'm going to have 1 over 1 plus x cubed squared times, all right, the derivative of x cubed, which is 3x squared. All right? So, by the way, we didn't need this up here. So my final answer is 3x squared over 1 plus x to the 6th. All right? Pretty easy. Let's look at another problem. This one right here. This is a very common wording in an AP calculus problem. If g of x is the arcsine of x over 2, then what is this thing? Well, that's just, this right here is just the definition of derivative, all right, at a point. Okay, this is the definition of derivative at a point. All right, so what it's really asking is, what is g prime of the square root of 3? All right, so we follow our formula for the derivative of the arcsine. All right, once again, all of our formulas are right here. We're going to use this one. So it's going to be 1 over the square root of 1 minus this thing squared times the derivative of that thing, which is just 1/2. All right, so again, just follow the formula. So this is going to be 1 over 2 times the square root of, now, this is 1 minus x squared over 4. I could clean that up and make it the square root of 4 minus x squared over 4, which means the square root of this 4 is a 2, right? And so the 2's are going to cancel out. And I'm left with 1 over the square root of 4 minus x squared. Okay? I'm just using the fact that if I have a radical over a fraction, all right, I can break it up into a radical over a radical. All right. On number 3, we have to use implicit differentiation because we have both a 3x and we have this y in here, and we'd have a difficult time solving this thing for y. So if we look at this thing just doing our implicit differentiation, the derivative of this side is going to be -1 over the square root of 1 minus 9x squared times the derivative of this, which is 3. On the right side, I'm going to have 1 over y times dy dx. And if I'm going to solve for dy dx, I just multiply both sides by y. And I have a final answer of -3y over the square root of 1 minus 9x squared. So you may have some problems that you have to do implicitly. And we will stop our video there for today.